U.S. consumer prices.
The rise in food prices.
Higher prices for groceries by as much as 20%.
Groceries have become ridiculously expensive. A few years ago, back in 2020, I decided to track exactly where my money was going. So I did what any logical person would do. I built a giant Excel spreadsheet. And for a while it worked. But let's be honest, manually typing every product, quantity, unit and price from a crumbled supermarket receipt is soul crushing. And at some point I just stopped. There was too much friction. Recently I decided to try it again, but this time with an app. I wanted something simple. Take a picture of a receipt, extract the products, store the prices, maybe help with inventory and maybe help with budgeting. I found apps that got close, but almost all of them came with one of three catches: a subscription, an account, or cloud AI processing. And especially that last one was a deal breaker for me. Because the moment an app uses cloud processing or requires an account, your data isn't just on your phone anymore. It is uploaded and stored on someone else's servers. And that means they can analyze it, monetize it, or even sell it. And even if they don't, data breaches happen all the time. So that same data can end up being exposed anyway. Grocery data is a silent diary. It tracks your discipline, your stress, and the exact moment you gave up on your New Year's resolutions. All without you writing a single word. I did not want to hand a diary to a corporation and hope they'd be ethical. Plus paying a subscription fee for an app that's meant to help you budget. Well, the irony wasn't lost on me. I apparently wanted the impossible. No account, no subscription, 100% local processing. I couldn't find an app that did that, so I made it myself. Before we get into the technical side, let me show you what the app actually is. At the highest level, it is a local grocery system. The receipt scanner is just a front door. Once the receipt has been scanned, the first screen you land on is the review screen. This is where the app turns a scan into something you can actually use. You can correct product names, adjust quantities, and choose the right unit. The app can also suggest product names based on what it has seen before. And it learns from your corrections. Once you save the receipt, the data goes into the local database. And from there, the rest of the app builds on top of it. The purchase history screen is the simplest one. It is just the history of what you bought. You can open all the receipts, look at the receipt photo, and see structured data that was saved from it. The inventory screen has that same purchase data and uses it to estimate what is still in stock. Usage is tracked manually, but I tried to make it quick. You move a slider, press one button, and it logs the amount you used. And if something's almost gone, you can send it straight to the shopping list from the inventory. The shopping list builds on top of that. It estimates the total cost of the list based on what you paid for the products before. And it also shows the value of the items you've already checked off. You can keep separate lists for different supermarkets, and you can reorder categories to match your preferred route through the store. So the list follows the way you actually shop. The recipe book connects to the same system too. It can compare a recipe against what you already have in your inventory, show what is missing, and add those missing ingredients to the shopping list with one tap. And if you want to cook for more people than the recipe asks for, you can scale up the recipe with one button. Then there are the insight screens. That is where your totals, product prices over time, and longer term trends come together. So you can see how your grocery spending changes over time. One of those screens is also fully customizable, so you can choose which data you want to focus on. And then there's the budget screen. That is where you can set a budget and immediately see how much you have already spent this week or month. There's also a widget for it, so you do not have to open the app to check your budget. And these are just a few of the highlights. Each screen has its own job, but they all work from the same local data. That's really the bigger idea behind the app. The receipt scanner is not the whole product. It is a starting point of a bigger local on-device system. The QR code for the app is on screen right now, and you can find a link in the description. Just a quick legal disclaimer, the app provides the data but takes zero responsibility if your final meal ends up on r/kitchen sales instead of r/kitchen chats. But building a scanner that works offline and still produces usable structured grocery data was not trivial, because receipts are messy and far from consistent. I glanced over it at the beginning, but there's a lot happening in between taking a picture and the review screen. So I'm going to break it down into 4 steps. First, the app takes and fixes the photo. Then it reads the text with OCR or optical character recognition. Then it figures out where the product rows are with a machine learning model. And lastly, the OCR data is combined with machine learning data in the parser to produce structured grocery data. That's the bigger picture. Let's get into it with more detail. The first step is just getting a usable image. The app lets you take a photo directly or import one from your gallery. You can crop the image and fix the perspective just by dragging the crop corners into the corners of the receipt. Once the corners are locked in, the app applies a perspective transform. In simple terms, it takes the receipt photographed at an angle and warps it so it looks much flatter. I am basically using linear algebra just to be able to read the word milk, and that step makes a huge difference. So before the optical text recognizer even starts, the app tries to make the receipt easier to read, because if the input image is bad, everything after will be worse. Now we get into text recognition. If you are not familiar with the term OCR, it just means turning a bunch of pixels into text the app can actually work with. The OCR also knows the exact location of the text on the receipt. This is important later on. One of the biggest surprises during development was that more image processing did not necessarily help. I tried brightness tricks, thresholds, sharpening, contrast boost, all the usual stuff. But a lot of the time, it made the results slower and worse. Turns out that making a receipt look like a deep fried meme from 2019 does not make it easier to read. So the current approach is much more neutral. But raw text alone is not enough, because OCR does not understand meaning, it just guesses characters. The app also uses a massive local product dictionary. The dictionary contains over 366,000 known product terms. This is not just food, it includes pantry items, drinks, household products, cleaning products, and lots of supermarket style product names and brands. So when the app checks the OCR quality, it doesn't just ask, did I read text? It also asks, does the text look like real grocery data based on the dictionary? It looks at individual words, like milk, but also at combinations of words that commonly appear together, like milk, chocolate. And later during the review, it can even suggest corrections if something looks slightly off. It will remember those corrections and corrects it automatically the next time around. Because Coke and cake are only one letter apart, but they can lead to 2 very different Friday nights. Now I have a bunch of text, then what? Even when the text is readable, there's still another problem: structure. The app doesn't just need to read words, it needs to know which words belong together. So the question becomes, what does a real product row look like? If every store printed receipts the same way, some rules would work fine. Products on the left, prices on the right, one clean row per item. But real receipts are chaotic. Some products take 2 lines, some stores insert random codes, some prices are vague, and sometimes the totals look like normal products. So instead of writing endless special cases for each supermarket out there, I let a model learn the patterns. This is exactly what machine learning is good for. Its job is simple: look at a receipt and predict where the item rows are. To train it, I corrected receipt images and manually drew boxes around real product rows. If it's a real item, it gets a box, anything else gets ignored. Those labels are then exported in a YOLO format, which stands for you only look once, which is a deeply ironic name because I definitely did not look at those receipts only once. Those labeled images are then used to train the model. The model makes a guess, then compares it to the correct answer, and then adjusts slightly. It repeats this process thousands of times. Over time, the model learns the visual structure of the receipt, where rows are, how they're spaced, and what separates real items from noise. And once the model is trained, it can place boxes on receipts automatically. Those boxes do not replace OCR, they do not decide what you bought, they just give the rest of the system a map. And that map makes everything else more reliable. Now the app has the text, the map, it just needs to stitch everything together. Once the app has the text locations, and the row structure, the parser combines those layers and turns them into a structured receipt. The boxes from a trained model are used as guidance. If the OCR text falls inside or very close to the same detected row box, the parser treats them as likely belonging together. So the model gives the parser a layout map, and the parser uses that map to group names, prices, and quantities into likely product rows. In general, more detected boxes means more candidate product rows, although not every box necessarily becomes a final item. That means the store name, the total, the date if it can find it, and the list of products with quantities, units, and prices when those can be inferred. But this is also where the app tries to stay honest. Receipts are messy, Text recognition is not always perfect, and the model is not perfect either. So instead of pretending the result is always flawless, the app is built around the review step. Before saving, you can check the result. If a product name is slightly wrong or a quantity is missing, you can tap and fix it. This is the human in the loop part, which is just developer language for please double check the machine before you accidentally log that you bought a banana for $400. And the cool part is the app can actually learn from those corrections locally. There are two kinds of learning happening here. The first is learned corrections. If you keep correcting the same weight abbreviation into the same product name, the app can remember that locally and apply that correction the next time around. The second is history-based guidance. If you bought the same product before at the same store, the app can use that earlier purchase as a clue. For example, imagine milk. It comes with the price, but the quantity is unclear. The app can look at an earlier entry from the same store, compare the price per unit pattern, and if it checks out, use that as a hint to autofill the missing amount. So if you bought 2 liters of milk for $1.75 and then buy milk again for $1.75, the system assumes that you bought 2 liters of milk based on your previous entry. And if it guesses wrong, you can just change it. And the app keeps learning from you over time. So the system gets better over time without any cloud use. And because building a fully local receipt scanner was not enough, I decided to add a Gamify feature. As you use the app, you can unlock scan animations, skins, themes, achievements, and even home screen titles. It does not change the core functionality of the app, the scanner still just scans receipts. This is just a layer on top that makes it feel a bit more alive. And if that sounds unnecessary, that's totally fine, because you can also just turn it off and keep the plain version of the app. I will probably keep adding more skins over time, although I should mention that I'm not an artist, so the artistic quality might fluctuate slightly. I do really like how the Japanese theme worked out though. So full transparency on monetization. The app starts with 10 free scans. After that, you will get 5 free scans every single month. So if you only do groceries like once a week, you can realistically use the app without ever seeing an ad. If you need more, you can watch one ad for 2 extra scans. There are no pop-up ads, no forced interruptions, and no moments where the app suddenly decides it is now an advertising platform. You only watch an ad if you choose to. You are the initiator, which was really important for me. And if you want unlimited scans, you can make a one-time purchase for $10 or so. I think it's pretty reasonable, especially considering that some comparable apps charge around €6 a month, which adds up very quickly. There are a lot of options available, anything from language to debugging tools for a look under the hood. But I also did not want new users to get buried under a wall of settings on day one. So there will be onboarding if you boot up the app for the first time. It is designed to be simple and user-friendly, and anything you choose can always be changed in the settings later on. There's also a help improve the app section planned as a future opt-in feature. The idea is simple. I trained the current machine learning model on 1000 receipts. Better models need more data, so if a user explicitly chooses to share their receipt data for training purposes, the model accuracy can improve over time. And just as important, there will also be a delete my data option. So users can remove their uploaded receipts from future training data with one tap. That is exactly how I think this kind of model improvement should be done. Transparently, ethically, and by explicit choice. Everything you share will be opt-in. The app will always be able to function offline. So this project started off as something I just wanted to make for myself, and I figured it would only take me a few days to get it working, but I was very wrong. I can code, like I made 2 small apps before, but this one's definitely the most complex app I've made so far. I had no idea how difficult it was to read a receipt. I was not intending on using machine learning as part of the solution, but it ended up working surprisingly well. Like I spent an entire day just labeling all of those receipts, but it worked. I was kind of happy with that. I kept working on the app and it slowly grew into something much bigger with way more features than what I actually wanted in the first place. Feature creep is definitely name of the game here. But yeah, it's pretty cool now. It's surprisingly complex. I even added some features that I didn't even mention in the video. For example, you can export and import your data. You can even export everything to a PDF file or an Excel spreadsheet if you want to. Like it just does it. And most important, pirate is a language option. So it's pretty cool. If it does like well on the App Store, I can look into making an iOS version. I would have to replace some Android specific features with iOS friendly ones, but it's definitely doable. If you want to support my future projects, you can check me out on Patreon. I will be sharing some more stuff over there as well. Don't forget to like, subscribe, and I will see you in the next one.